Imagine this. Every single human alive today, every culture, every language, every story, all of it traces back to a moment when our species almost didn't make it. About 930,000 years ago, our ancestors faced a crisis so severe that their entire population may have dropped to just over 1,000 breeding individuals. That's fewer people than you'd find in a small town today. For over 100,000 years, humanity teetered on the edge of extinction. This isn't a guess pulled from thin air. It's a clue hidden in our DNA, uncovered by scientists in 2023. By analyzing the genetic signatures left behind in modern humans, researchers pieced together evidence of a dramatic population bottleneck, a time when the human lineage was crushed down to almost nothing before slowly recovering. What could have caused such a collapse? Climate chaos, resource scarcity, or something else entirely? And more importantly, how did we survive when the odds were stacked against us? The story of our near extinction doesn't come from a single fossil or artifact buried in the ground. Instead, it was discovered inside us, in the DNA of modern humans. In 2023, a team of researchers from China, Italy, and the United States published a study in Science that shook up our understanding of early human history. They used a new statistical method called FIT-COAL, short for Fast Infinitesimal Time Coalescent Process, to analyze the genomes of more than 3,000 modern people from across the world. What they were looking for was subtle, patterns in how genetic variation is distributed today that could point to ancient population changes. What they found was startling. Around 930,000 years ago, the human lineage went through what's known as a population bottleneck. That's when a species' numbers shrink so drastically that only a tiny fraction of individuals contribute their genes to future generations. In our case, the researchers estimate that the effective breeding population collapsed by about 98.7%. Instead of millions spread across Africa as we might imagine, there may have been as few as 1,280 reproductive individuals left, a number comparable to the passenger list of a single cruise ship. Even more astonishing is how long this crisis lasted. The genetic data suggests the bottleneck stretched over roughly 117,000 years, from around 930,000 until about 813,000 years ago. That's not just a brief catastrophe, it's multiple generations, thousands upon thousands of years, where survival was a razor's edge. And yet, our ancestors endured, maintaining just enough genetic diversity for humanity to eventually rebound. But it's important to understand how scientists arrived at this conclusion. Geneticists can't time travel to count populations directly. Instead, they work backwards from DNA, using mathematical models to simulate how gene variants would spread under different scenarios. When the modern genetic data line up with a particular model, it suggests that's what likely happened in the past. Of course, this method comes with caveats. It assumes certain mutation rates, population structures, and patterns of inheritance. A miscalculation in any of these could shift the timeline or the severity of the bottleneck. Still, the numbers line up with something puzzling in the fossil record. There's a gap in human fossils and archaeological sites between about 950,000 and 650,000 years ago. We know hominins existed before and after this window, but evidence within it is sparse, as if our ancestors had dwindled so much that their presence barely left a trace. The genetic bottleneck and the fossil gap reinforce each other, making the case stronger that something dramatic really did happen. This raises the obvious question: what on earth could have caused humanity to shrink to the edge of extinction? If the genetic data is right, something extraordinary happened 930,000 years ago to nearly erase the human lineage. But what could force a species as adaptable as ours into such a long and devastating decline? The truth is, we don't know for sure, but scientists have some strong suspects. The leading explanation points to climate. Around that time, Earth was entering what's called the mid-Pleistocene transition, a period when the planet's glacial cycles grew longer, colder, and more extreme. Instead of brief ice ages followed by quick warm-ups, the rhythms of the climate shifted into drawn-out freezes that could last hundreds of thousands of years. For early humans, this meant harsher winters, drier landscapes, and massive swings in the availability of food and water. Habitats shrank and fragmented. Regions that once supported hominins may have become uninhabitable deserts or tundra. Populations that had been spread across Africa and possibly beyond were suddenly squeezed into smaller, isolated refuges. Environmental stress wasn't the only factor. With resources scarce, competition with other hominin species could have sharpened. Around this time, multiple human relatives were still on the scene. Early Homo erectus in Asia, for example, and perhaps unknown lineages in Africa. Did our ancestors lose ground to rivals? Or were they simply unlucky, caught in ecological traps that others managed to avoid? There's also the possibility of disease. In small scattered populations, epidemics can be devastating. A pathogen sweeping through one group could wipe them out entirely, leaving only a few survivors in isolated pockets. Another factor may have been geography. Africa, the likely home of our lineage during this time, experienced severe droughts linked to shifting monsoon patterns. Some regions may have acted as refuges, places with permanent water or reliable plant and animal life, while much of the continent became too dry to support human groups. If only a handful of populations were able to hold on in these refuges, that could explain why numbers plunged so dramatically. Yet, despite these plausible explanations, the bottleneck remains mysterious. The study that uncovered it doesn't assign a single cause, and some anthropologists remain cautious. Climate models support the idea of environmental stress, but whether that alone could reduce the global population to around 1,000 breeding individuals is still debated. Some suggest the bottleneck might not have been truly global. Instead, maybe it reflects the crash of one lineage that eventually gave rise to us, while others disappeared without leaving genetic traces. What we can say is that something profound reshaped the destiny of our ancestors during this period. Survival wasn't guaranteed. Most hominin lineages in Earth's history have gone extinct. For reasons we're still trying to piece together, this tiny group managed to hold on. If our ancestors really dwindled to just a few thousand individuals, survival wasn't a matter of thriving. It was about scraping by. Picture scattered bands of early humans, living in small groups no bigger than a modern village, isolated in pockets of Africa, where conditions hadn't completely collapsed. These weren't lush refuges filled with plenty. They were harsh landscapes that only offered enough to survive if people adapted fast. One key to survival may have been geography. Certain regions, such as the Great Rift Valley in East Africa, contained lakes, rivers, and varied terrain that could buffer against climate swings. When rainfall failed across much of the continent, these places may have still provided water and edible plants. Groups who found themselves in these refuges would have had a chance to endure, while others vanished. Another factor was cooperation. In populations that small, every individual mattered. Sharing food, protecting children, and passing down survival knowledge would have been the difference between making it through lean years or disappearing entirely. Anthropologists suggest that social bonds may have become even more critical in these times, cementing behaviors that later became central to human success. Technology may have played a role as well. Evidence for controlled fire use is debated this far back, but if any groups had mastered even basic fire handling for warmth, cooking, or protection, it would have given them an enormous edge. Stone tools were definitely in play. Hand axes and cutting implements from this era show that our ancestors had already developed versatile ways to butcher animals, crack bones for marrow, and process plant foods. Flexibility in diet, being able to eat whatever the landscape offered, may have been one of the most important survival skills of all. But survival at such low numbers came at a cost. A bottleneck this severe would have stripped away a huge amount of genetic diversity. Think of it like narrowing a river into a tiny stream. Only a small portion of the genetic variation present in earlier populations flowed forward into the future. This meant inbreeding was unavoidable, and harmful genetic variants may have spread more easily. Paradoxically, some scientists argue that such bottlenecks can also purge damaging mutations from a population, leaving behind a cleaner genetic slate. In other words, the very pressure of being reduced to so few may have shaped the genetics of modern humans in unexpected ways. Eventually, around 813,000 years ago, the genetic record suggests populations began to rebound. The reasons for this recovery are unclear. Maybe climate cycles shifted again, opening up new habitats. Maybe new skills spread, like more advanced toolmaking or reliable fire use. Whatever the cause, our ancestors began climbing back from the brink. Slowly, group by group, their numbers grew, setting the stage for the later evolution of Homo heidelbergensis and eventually Homo sapiens. It's humbling to think about. For over 100,000 years, humanity's entire future balanced on the survival of just a few scattered families. Every one of us alive today carries the legacy of that survival, the genetic fingerprints of a lineage that should have disappeared but didn't. The discovery of a human bottleneck 930,000 years ago forces us to rethink the story of our origins. For decades, anthropologists assumed early humans steadily spread across Africa and beyond, gradually evolving and diversifying. But the genetic evidence paints a far more precarious picture, one where our lineage nearly collapsed before it had a chance to flourish. If true, this bottleneck explains a few long-standing puzzles. One is the strikingly low genetic diversity among modern humans compared to other primates. Chimpanzees and gorillas, for example, carry far more variation in their DNA than we do, even though their populations are smaller today. A severe crash early in our history could have flattened much of our genetic diversity, leaving us with a narrower gene pool than other great apes. But the implications go further. A bottleneck lasting over 100,000 years suggests that human evolution wasn't a steady march forward. It was fragile, contingent, and deeply shaped by environmental forces. If our ancestors had been reduced by just a little more, humanity might not exist at all. The survival of that tiny remnant set the stage for everything that followed, from the rise of Homo heidelbergensis to Homo sapiens, and ultimately the global spread of our species. That said, the theory isn't without controversy. Some researchers question whether the bottleneck was truly global. Genetic modeling can suggest a population collapse, but it's possible the signal reflects just one lineage, the one that gave rise to us, while other groups lived elsewhere but left no descendants. Fossil evidence is another sticking point. There's a known gap in the archaeological record between about 950,000 and 650,000 years ago, which seems to support the genetic story. But absence of fossils isn't proof of absence. It may simply be that the fossils from this period haven't yet been found, or that they remain buried in regions we haven't searched thoroughly. The methodology itself has limits too. Back-projecting from modern DNA relies on assumptions about mutation rates, population mixing, and inheritance patterns. Change the parameters, and the timing or severity of the bottleneck could shift. Critics argue that the model may be overinterpreting the data, especially given how messy human evolution was, with multiple hominin species interbreeding and moving across continents. Still, the fact that the genetic signal aligns with a gap in the fossil record makes the bottleneck hypothesis hard to dismiss. Even if the exact numbers, 1,280 breeding individuals, 117,000 years of crisis, are debated, the broader point stands. Early humans faced a profound population crash. Whether it was global or regional, it left a lasting imprint on our DNA. The next step will be finding more evidence. Fossils from this shadowy period of prehistory could confirm or challenge the genetic model. Ancient DNA from older hominins, if any can be recovered, might reveal whether the bottleneck signal is universal or limited to one branch. For now, we're left with a haunting possibility, that humanity's future once hinged on the survival of a population small enough to fit into a football stadium. Looking back at this near-extinction event, it's hard not to feel a sense of awe. For more than 100,000 years, our ancestors lived on the edge, their survival never guaranteed. They weren't kings of the planet, inventors of cities, or explorers of oceans. They were fragile, scattered, and vulnerable, clinging to life in small pockets of land, while most of the world became too hostile to inhabit. And yet, somehow, they endured. That endurance is a reminder of just how fragile human history has been. It's easy to look at our species today, billions strong, reshaping the planet itself, and assume we were destined to dominate. But the truth is that the entire story of humanity balanced on a knife's edge. A few thousand fewer survivors, one more failed generation, and our lineage could have vanished alongside countless other hominins that never made it. It also reshapes how we think about what it means to be human. Our survival wasn't driven by strength alone. It likely came down to cooperation, adaptability, and the ability to make the most of whatever environment was left. Those traits, flexibility, ingenuity, and social bonds, became the foundation of our later success. In a way, the bottleneck may have forged the very qualities that allowed our descendants to eventually spread out of Africa and colonize the globe. There's also a sobering lesson here. Many species today are going through their own bottlenecks, from cheetahs with dangerously low genetic diversity to critically endangered rhinos and orangutans. The human story shows that survival is possible, but it comes with lasting consequences. Reduced diversity can leave a species more vulnerable to disease, climate shifts, and ecological change. Our ancestors got through it, but there was nothing inevitable about their escape. So, the next time you think about human history, remember that it isn't just a story of progress. It's also a story of near loss, of fragile survival against overwhelming odds. Every person alive today carries the genetic echoes of a moment when humanity nearly disappeared forever. We are, quite literally, the children of survivors, the lucky few who made it through the darkest chapter of our past.